Good afternoon, class. So today we're looking at trigonometry, 3D problems, 3D and 2D problems. Okay, so we went through the basics again. So now we're looking at worked example 1 on page 121, and this is for exercise 1 on page 121. Okay, so we are told that in triangle PQS, so we got triangle PQS, R is the midpoint. So if R is the midpoint, we know that QR is equal to RS. So QR is denoted with the letter D, so QR and RS would be D. We are also told which is also equal to PR. So all these lengths will be marked with the lowercase d. Then we're told that PS is A, that length of PS is A, and angle PQR is equal to theta. As you can see, it's marked on the diagram as well. The question says prove that A is equal to 2D sine theta. A is equal to 2D sine theta. Okay, so as we did in grade 11, we try and start off with that angle, over that length there, A. Okay, so if you look at A is lying there. So we need to know this angle here at least. Okay, because we know that is D and that is D. So you can use the cos rule here. Okay, because you see we got two lengths, and if we got that angle PRS, we got that angle sorted, then we can use the cos rule. You all agree with that? Okay. Otherwise, if we go and calculate S and angle P in triangle PSR, then we can use the sine rule as well. Can you all see that? Alright. So let's go. What can be determined at this point? We know that this angle here is equal to, what's the size of this angle? Theta. So why is angle QPR equal to theta? What? Angles opposite equal sides. Angles opposite equal. Okay. So what's the size of this angle? What's the size of that angle? Sorry? 2 theta is. Why is PRS equal to 2 theta? Exterior angle of triangle, not so. So that's going to be exterior angle of triangle, and that is triangle PRS. Okay, so that's 2 theta. Okay, I'm going to go down using the sine rule. Okay, at this point I could have used the cos rule if you want. Okay, so I'm going to go and use the sine rule, but for the sine rule I need another angle here. Okay, so I need to work out what angle S is. Okay, but we know that angle S is equal to angle SPR. So you say angle S is equal to angle SPR. Why? Because it's angles opposite equal sides. Okay, so those angles are equal. So I'm just going to represent angle S in terms of theta. So we know that angle S plus angle SPR plus 2 theta is equal to 180. Why? Sum of triangles. So 2 theta plus twice angle S is equal to 180. You all agree with that? Because S is equal to SPR, so I can replace SPR with an S. Okay, so that I can have one unknown in this equation. And the reason here is sum of triangles. And it's triangle PRS. Alright. So now I'm going to make this the subject of the formula. So angle S is equal to 180 minus 2 theta divided by 2 which will give us 90 minus theta. Okay, which is also equal to SPR. That is 90 minus theta. Is there any confusion at this point? No confusion. Okay. I just need to take this off. So I'd like to keep the diagram in focus. Now we can go with the sine rule. Okay. So now we say, okay, A over sine of 2 theta equals, what is this then, the value of, and what is the length PR? Also D. So it's going to be D over sine 90 minus theta. Okay. So again, we will need to make A the subject of the formula. Not so. So what we do? Cross multiply. Or you could have just taken sine 2 theta up. But some I know, some of you can't do that. So that would be A sine 90 minus theta is equal to D sine 2 theta. Then we divide both sides by 90 sine 90 minus theta. So that would be A is equal to D sine 2 theta over 90 sine 90 minus theta. But what can we do to sine 2 theta? Well, then can be written as sine, sorry, what can sine 2 theta be written as? 2 sine theta plus theta. So it's going to be D times 2 sine theta cos theta. What will happen here? To sine 90 minus theta. Cos theta. So what's going to happen now? The causes cancel. Not so? And D times 2 sine theta is going to be 2D sine theta. And that's what they wanted us to do. You guys understand? So do it again. No. Okay, so you guys understand, huh? Alright. Do it again. Let's try again. Okay. Okay, so the question says that in triangle PQR, PQS, angle R is the midpoint. So if that's the midpoint, that will also be D. That will be marked D as QR was marked D. Okay. Then we are told that PS is A and PQR is theta. The question says you must prove that A is equal to 2D sine theta. Okay. So as you can see where A is lying on that side of the triangle. If you look at it and we work with the triangle there's nothing we could have set up in terms of sine with cosine rule. Okay? We don't have two angles on the side, neither do we have two sides in an included angle. Okay? So in other words, we needed to find another triangle with A in it. We need to pick up A. So that is one triangle and here's the other. And I say, okay, we can work with that. There's two angles, there's a D and a D here, with those two lengths. And I got A, and now I can work out that angle there as well. Okay, so all of those things we're looking at from the beginning. Okay, so we said, okay, to calculate A, we're going to work in triangle PRS, so we needed this angle. We know that PRS is also equal to angle theta plus that angle there. Right. But we know that QPR is equal to theta. Okay, why? So that's angles opposite, equal sides. You understand, Michael? Huh? Yes? That is angles opposite, equal sides. Right, so that's theta here. Then we know that this angle here is an exterior angle of that triangle. Exterior angle is equal to the sum of the two interior opposite angles. Not so? So we say PRS is equal to 2 theta. exterior angle of triangle. Okay, and that is triangle PRS. The exterior angle of triangle PRQ, sorry. Okay, so there's 2 theta. Okay. So we say we could have used the cos rule as well. Not so? So let's try the cos rule. So now we're working in triangle PRS. You see we got 2 lengths and included angle. Can you see that? So the cos rule could have been applied there. Let's see if we can get that out. So the cos rule is going to be a squared is equal to d squared plus d squared minus 2d by d cos of 2 theta. Okay. So what is d squared plus d squared? 2d squared minus 2d squared cos of 2 theta. But if we look at what we need to prove and what we got thus far is not the same. Not so. So what we do is we're going to change cos. Cos of 2 theta can be written as 1 of 3. Which one do you think we're going to use here? 1 minus 2 sine squared theta. Why that one? Because we have a sine here. Can you see that? So that would simply be 2d squared minus 2d squared into 1 minus 2 sine squared theta. Okay? See, this is a bit longer, no? No, we deleted some stuff. Erase some stuff. So we multiply that in. So it's going to be 2d squared minus 2d squared plus 4d squared sine squared theta. So what happens? That cancels. So a squared is equal to 4d squared sine squared theta. Take the square root both sides. Remember that a has to be positive because I'm talking about length. The square root of 4 is 2d sine theta, which is again what they are looking for. Okay, so there's 2 ways of doing it. Yes? Okay. Any other confusion here? So with that you should be able to do exercise 1. Okay. Let's start with it now.